So question 6, it says at time t seconds where t is greater than or equal to 0, a particle p moves in the xy plane in such a way that its velocity is given by that there. But what I don't want to do is write out things in terms of I and j. It's always easier to use column vectors for this. So v is equal to, and the I component is t to the minus 1/2, and the j component is minus 4t. So it says when t equals 1, p is at the point A, and when t equals 4, p is at the point B. Find the exact distance, AB. Well, we need an expression now for position or displacement, which we know is the integral of velocity. So integrating velocity, we get, so add 1 to the power, t to the power of 1/2, divided by 1/2, which is the same as timesing by 2. And then minus 4t integrated becomes minus 4t squared over 2, or minus 2t squared, plus a vector constant. And we now need to find out what that constant is. So let's just summarize what we just found out. We know that displacement now is this vector here. So it's 2t to the 1/2 plus a constant 1, and the j component is minus 2t squared plus a different constant. So what we're going to do now, reading this here, it says when t equals 1, p is at the point A. So we're going to say that A is the point 0, 0. We're going to consider A to be our origin. And that will allow us to find the values of the constants if we refer everything to the point A and call A the origin. So let t equal 1 and the displacement equals 0, 0, i.e. it's at the origin. This implies that s equals, so 2t to the 1/2, and this time t is 1, so 2 lots of 1 to the power of 1/2 plus our constant 1. And then this component will be minus 2 lots of 1 squared plus our constant 2. And we know the displacement at this time is 0, 0. Which means that 2 plus c1 equals 0. Which means that c1 equals minus 2. And minus 2 plus c2 equals 0. Which means that c2 equals 2. Therefore, our displacement formula for which we've got here, we can write with the values of the constants in there now. So it's 2t to the 1/2 minus 2 and minus 2t squared plus 2. So now we find the displacement when t equals 4. So let t equal 4, which means that our displacement vector is 2 lots of 4 to the 1/2, take 2, and minus 2 lots of 4 squared plus 2 equals, well, this top one is 2 times 2, take 2, which is 2. And the bottom is minus 2 times 16, so minus 32 plus 2, which is minus 30. Therefore, the length of our displacement equals square root of 2 squared plus 30 squared. Let's work that out. So square root of 2 squared plus 30 squared equals to 2 root 226. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.